In this video, we'll walk you through how Fabric Real-Time Intelligence simplifies building a smart building monitoring system that provides you real-time insights and enables you to respond the moment data arrives. Our journey begins with the Real-Time Hub, which offers easy access to a wide range of connectors for ingesting data. These include messaging brokers like Azure Event Grid, Service Bus, MQTT, and Google PubSub, as well as streaming brokers such as Azure Event Hub, AWS MSK, and Confluent Kafka. You can also bring in change data capture, CDC, streams from databases like Azure SQL DB, PostgreSQL, MySQL, and more. In our example, the sensor data comes from an MQTT broker. Let's start by selecting the MQTT connector, creating a connection, and entering the topic name. Next, we'll name our event stream and click Next. After reviewing the configuration, we click Connect. This creates an event stream and adds the MQTT source. Now let's open the event stream. Our next step is to add another source, weather data, to provide environmental context for the buildings. We'll select Connect to Sources, search for weather. The data is coming from Azure Maps Weather. First, we select a location. Let's assume our buildings are in London, one in Greenwich and one in Westminster. We'll name each source accordingly to distinguish them. Repeat the same steps to add the Westminster weather source. Once both sources are added, we'll publish the event stream. After publishing, you'll see the weather data flowing in, which include temperature, wind, precipitation, location information. Now we'll enter Event Stream Edit mode. Use the newly released custom code with SQL feature to transform the weather data into a format that's ready for downstream consumption. The SQL operator lets you use familiar syntax to perform advanced processing efficiently. In this example, we add location metadata, convert temperature from Celsius to Fahrenheit, and include latitude and longitude to enable map-based visualizations. One important step: don't forget to define the destination for your transformed data. The test query feature lets you instantly test and debug your setup. Once you've saved the SQL query, you can configure EventStream to send the reshaped weather data to the event house table. After publishing, you'll see the weather data streaming into the table in the expected format. Now that the weather data is in good shape, let's move on to processing the sensor data coming in through MQTT. We're receiving 3 types of sensor data and each with a different schema. To handle this, we'll first enable the multiple schema inference feature. After configuring it in the settings, you'll see a new schema option in the data preview. EventStream will automatically infer the schema based on the incoming data, and each schema will be listed separately. In this case, we have 4 schemas, one each for temperature, power usage, and room occupancy sensors, plus the weather data we processed earlier. This schema separation makes data transformation much easier. Now, in EventStream's edit mode, we'll filter the MQTT data into 3 separate streams based on sensor type. Thanks to schema inference, it's easy to isolate the schema we want to work with. Let's start by filtering for sensor type equals temperature. Next, we'll use the Manage Fields operator to define the structure of our table. As you can see, the fields are already parsed for you, including nested JSON. You can also rename fields or update their data types if needed. Once that's done, we'll send this stream to the temperature table in Event House. We'll repeat the same steps for the power usage and room occupancy streams, and route them to their respective tables in Event House as well. Now let's open Event House and check the tables receiving the MQTT sensor data. As expected, the 3 types of sensor data have landed in their respective Event House tables, each in the correct format. Next, we'll add Activator as a destination in EventStream to enable real-time actions when specific conditions are met. First, we add Activator as a destination and create a new one called Temperature Activator. With this activator, we want to receive a Teams message whenever the room temperature reaches or exceeds 80 degrees. Then, we configure the alert. The trigger condition is when the temperature is greater than or equal to 80 degrees, and the action is to send a Teams message. We also include key parameters in the message, such as building name, room number, and current temperature, so the alert provides clear context. Once everything is set up, click Create and Start. Now let's run a quick test. Using MQTTX, we send a simulated MQTT message with a temperature reading of 81 degrees. As soon as the message is sent, we receive the alert in Teams, confirming that everything is working as expected. This setup allows us to respond in real time and take immediate action as events happen. Our MQTT and weather data all landed perfectly in Event House tables. Our last step is to build a real-time dashboard to monitor our building environment at real time. Now we can create a real-time dashboard. Let's name it as Smart Building Real-Time Monitoring Dashboard. After creating the dashboard, you can set the auto-refresh frequency in the Manage settings. In this case, we set it to continuous. With this dashboard, we can monitor multiple buildings, outdoor temperature with location in a map, power usage trend, room occupancy status, indoor room temperature trend, and hottest rooms ECT. It gives us the real-time insights into what is happening from environment perspective to each building. As you can see, this simple project would normally require extensive integration across MQTT brokers, public weather feed, Kafka brokers, time series real-time databases, and then reporting tools and alerts. Something that would take weeks if not longer. But with Fabric, you can achieve the same outcomes within hours or days at most. Thanks for watching.